Welcome to Kotlin Fundamentals. We're starting at the beginning, setting up your tools, learning the basics like variables, types, control flow, and functions. Then we'll jump into collections and lambdas, your secret weapon for handling data smoothly and writing smarter code. No confusing jargon, just straightforward steps to get you coding like a pro, minus the headaches. So, open up a web browser and search IntelliJ IDEA. Go to their official website, hit download, IntelliJ IDEA Community Edition, hit download. As you can see, I've already downloaded it. So we can open it. Let's get started with our first Kotlin program. So, you're gonna write fun, main, and a curly brace. So this is the function body, and this is the main function where every Kotlin program starts. So we're gonna print hello world using println function, println. So write hello world Kotlin, and then hit the green button. It's going to compile, and the output would be shown in the console right here, hello world Kotlin. And that's your first Kotlin program. In this lesson we'll learn variables, expressions, and constants. So, a variable is a named memory location used to store data that can change during program's execution. For example, in Kotlin we declare variables with var or val. Var is for variables that are mutable, which can be changed. So, for example, age can be changed. So you can mention your age here, and then we can also declare constant variables which are declared with val. These cannot be changed. For example, the value of pi, we don't want it to change, and if we try to change it, we're gonna receive an error. For example, here, val cannot be reassigned, and our program would not compile. So let's move this. We can write our name in this val constant variable, and we can also print these variables by using their name, age, and pi, and also the name. As you can see, 23.14 and my name. Next up we have expressions. Expressions can involve variables, operators, or function calls. So when you compound all these variables into a single line, we get an expression. For example, we can create this variable called expression, and we can chain these operations. We can chain operations like 2 times 3 plus 10 minus 11 divided by 2. And we can print this expression. You can see the output. And now let's discuss operators. The fundamental operators in Kotlin are plus, minus, division, multiplication, and modulus. So let's perform all these operations. 2 plus 3, or 2 maybe, and 2 minus 9, and then we have 10 divided by 2, for modulus 2, and finally we have the multiplication operator, 2 times 10. And now let's run. Let's just comment these out. And to comment code in Kotlin, you can use 2 forward slashes. And we can also use forward slash and an asterisk for multi-line comments. Like so. So this was a single line comment. And this was a multi-line comment. And once we're done with that, let's print. Now, as you can see, the result is visible. 2 plus 3, 5. 2 minus 9 minus 7. 10 divided by 2, 5. And 4 moduli 2 is 0 because the remainder when we divide 4 by 2 is 0. And 2 times 10 is 20. So that's operators for you. And let's deal with increment and decrement operations now. So to increment we can use double plus, and to decrement we can use double minus. Now let's say you have a variable called counter. So this variable counter is 0 initially, and then you counter plus plus, which is post increment. We can also do a pre-increment like so. And when we print our value we should get a 2, 0. Here counter plus plus means counter plus 1. And here also the same thing, counter plus 1, but the value plus 1 is added before we can use it. So let's find out the value of counter now. Which is 2. It's expected. We can also decrement using double minus sign, and pre-decrement 2 using 2 minus signs prefixed to the variable name. And now we should get, here it was 1 and 2. 2 minus 1 is 1, and then 1 minus 1 would be 0. So we should get 0 now, which we do. So that's increment and decrement. And now we should deal with math functions. Import math Kotlin.math, and to start to import all the functions in the math library. Now we're dealing with math functions. For example, square root, which is named as QRT, and power. We also have the normal scientific functions like sine, cos, tan. Now let's try these out. Square root of square root of 100, which is 10. But as you can see, we need a pointer value for this to work. We need a float value, which is basically a decimal value, so we cannot use integers here as the argument. So let's print this value. As you can see, our result is 10 with a decimal and a 0 as the trailing 0. Okay. And we can use the power function to find exponents. For example, 2 times 3. And again, it needs to be a float value. We'll discuss the data types in the next video. But for now, the result is 8. 2 to the power of 3 is 8. We can also find the sine, cosine, and tan. Sine expects a float value as always. Let's see, the sine of 0 should be 0. As you can see, we passed an integer instead of a double, and that's why we see this error. And now the error should be gone. Here, it's 0 now. And if we print the cosine of 0, 0.0, of course, and the tan, we should get 0, 1, and 0, because tan is 0 at 0 radians, and cos 0 radians is 1. We do have more functions in the math library, like log or logarithm. and log of 1 is 0. Let's make sure it's a double or a float. Okay, we also need to pass a base for this. And let's say the base is 10. And now we should get a 0 is expected. So that's all for this lesson. Meet you in the next lesson. In this lesson, we'll look at data types in Kotlin. Kotlin is a statically typed language, meaning a variable's type is known at compile time. It avoids implicit conversions, so you must explicitly convert between types. Using toInt, for example, or toString. But first, let's define these variables. So these are data types for integers. Let's look at these data types like so. Number 1, you type a colon and byte data class. Okay. Equals 127. The maximum number that a byte data type can hold. Next, let's define a short, which can hold a maximum of 32767. And for number 3, let's define an integer with int data type, and make sure you use a colon instead of a semicolon here to declare which type of variable you're declaring. And now we can define any number, which is a big number. And for fourth number, let's make this long. Make sure you end this with an L to indicate that it's a long data type. And now let's look at float and double. Both of these are for floating point numbers. For example, 4.3, 3.145768578, or any decimal number. So a float is less precise and a double is more precise. So to declare float variables, you can write float var decimal float equals 7.8. Make sure you end it with an F, where F is float. And for a double, you can have a more precise number like this. Now let's look at Boolean. A Boolean is a data type which stands for two values, true or false. So let's say is raining. Is it raining today? False. Or for a switch, a light switch. Is the switch on? If it's on, we can say true. If it's off, we can say false. So that's Boolean data type. We can also say, is player alive right now? So if it's true, then you can say true. If it's not, you can say false. So it's a very important data type. Then we have character and string. So a character is a single character. For example, all the alphabets, A to Z. Use single quotes for character data type. And for something like a name, with string data type should be surrounded with double quotes. So that's string. And you can see that I did not declare Boolean here. So Kotlin can infer that it's a false or a true value. That means it should be Boolean. But if we explicitly don't want any confusion, we must use Boolean here. But that confusion mostly arises when we use these types, a short or a byte, because an int can contain a byte and a short, because its maximum value is very, very high. So in case we must use byte, then we can declare it specifically, explicitly, by writing byte. Now let's look at any, unit, and nothing. What are these? So any, as you can think, any is a data type which can be any data type. Let's say you declare a variable with age and any. So any can take a string, or it can take a number. It can also take a float. It can take basically anything, any data type. All of these that we discussed. So what's unit? Unit is similar to void in other programming languages. So unit is basically when a useless data type that it does not mean anything. Like you can store something as a unit. Like this. So this print line function does not return anything. So when you do not return anything, you can say it's returning a unit. It's not returning anything. Next we have the nothing. Now you would confuse unit and nothing, but let's just say nothing is used when we have an exception. When we need to throw an exception, or a function that just keeps recursing and does not return anything at all, not even unit. So let's just throw exception. So maybe you don't see it here, but this is what it says about nothing. You can use nothing to represent a value that never exists. Unit does exist, but nothing, it doesn't exist. Okay, now that we're done with the basic data types, let's look at pairs and triples. So, a pair, as you might think, is used to store two values at the same time. For example, you can store a pair of numbers. Both are int type pair, 10 and 12, like so. And make sure it's not necessary that you define it explicitly here, but you should know how to do it. So first write pair, opening angle brace, and the first data type, and the second data type. It's not necessary that you make the data types of the two objects in the pair the same. It can be different. For example, you could have my score pair. This would be a pair of a string and an int. So pair and integer, let's say 98. Wow. So that's pair. String int. This is a string, this is an integer. Make sure it's exactly in order. Like string is first, and you should make sure the first data type that you write is max, which is a string, and the second is an integer. So triples, as you may think, are for storing three values at the same time. So let's say grades, and it would be a triple of 3 character data types, like so. And you write triple A plus and B. So this is throwing an error because you have more than one characters, but a character type can only store one character at a time. So let's make this C. And now we store data types, different data types, in one triple. Let's say movies. Triple string, the name of the movie, the rating of the movie, which would be, let's say, a float, and the duration. Let's say it's a string again, or maybe an int. Okay, let's make it movie and triple. So the movie's name is, let's say, Terrifier 2, and its rating is, let's say, 7.5. I don't know its exact rating, but let's just assume that's what it is. And as for the integer, how long it is in minutes, let's say. So 120 minutes. Okay, that's triples for you and Peter. This lesson we'll look at comparison operators, string template, if expressions, loops, while, do while, and for loop, and when expressions. So let's begin with the comparison operators. Let's say the age required is 18 and your age is 16. And if we try to compare this using the equality operator, like so, required age, two equal signs. Instead of your age, let's just say age. Yeah. So I'm using string template here, which is a better way to display variable values in your string. So is required age equal to age, then it should say false, because it's not. And it does that. Exactly. Now, you might ask, why not use something else? Why string templates? So if I use the primitive way of doing this, we'd have to do it like this. Is required age greater than age? Then we add a plus, concatenate strings, like so. Required age is greater than age. We're going to convert this to string, so we can add these two strings and display them. As you can see, it says true, because the required age is greater than age. Now, is required age less than age? And let's use template. Required age less than age. And this will return false. And now let's test not equal to symbol operator. Is required age not equal to age? Dollar sign, curly braces, required age not equal to symbol and age. And this should return true, like it does. Okay. Now let's look at if expressions. Okay, before that, greater than equal to, if we test it here, means if the required age is greater than or equal to the age. It is greater than, so it's going to return true, even though it's not equal to age, but it is greater than that, so it will return true. And it does. And less than equal to, will return false. Okay, now let's look at an if and else expressions. If, let's comment this code, and let's declare a condition. If marks, if the marks are 80, and let's say if the marks are greater than 90, then you say great job. Else, in the case it's not greater than 90, then you can say better luck next time. And this will return better luck next time right now because the marks are less than 90. And it does. In the case that the marks were 100, it will return great job, like it does. So that's if and else. You can also add more conditions like if marks are exactly equal to 85, and you can say you're getting there. Let's make this 85 to get this result. As you can see. Now, there's also an else if, which we can use for logical conditions. $75. And actually we should use else if in our case where marks can change accordingly. Marks says 75, 85, or greater than 90. Okay, if it's 75, then average performance. Let's make it 75. So first we'll check if the marks is greater than 90, which it's not. So it's going to skip this. It's going to go to else if marks are 85, which is not true. So we're going to skip this too, and marks are 75, which they are. So we'll print this and skip this. So it should say average performance, as it does. Now let's look at loops. Comment this out. With control and // you can do that. Okay, now let's look at loops. So let's start this at 0, counter variable. Let's just say count is 0. While some condition execute the code between these curly braces. That's what a while loop does. So you specify your condition here. That would be count is less than 10. And inside this, let's just print something. Let's say we print an emoji. And we increment the count as discussed in the previous lesson. Now if we click the screen button, which is run, we can see the output, and there must be 10 of these emojis. Okay, so let me show you how you can iterate through this while loop. So the count is 0 in the first iteration, and we print this, and the count goes up to 1. Now the while loop ends and starts again here. Count is less than 10, which is 1 is less than 10 now. So it's gonna execute this print line again, and the count is gonna go up to 2. And this will keep happening. Let's say the count would become 9. And it would print this, and then the count would become 10. And 10 is less than 10 is not true, it's false. So the while loop execution stops there, and you get 10 of these printed emojis. 10 times the printed emojis. Now let's look at the do while loop. So do something while the condition is true. Let's just say and a string template. Okay, let's define I equals 0. While I is less than 10, we're going to keep looping and keep executing this code between these two curly braces. Let's try this out. Okay, we ran into an error because we never incremented, and it's always less than 0. So it will keep looping and create an infinite loop, because I is 0, and then it's always 0. So we need to increment it, and now it's going to run 10 times. And it does 0, 1, 2, 3, 4 till 9. So in case of a do while loop, the loop always runs one time before it checks the condition, even if this is false. Let's say I equals 10. We're gonna get hello 0, because it always runs it once. Yeah, that rhymes. Hello 0. Yes. So a do while loop always runs once, no matter the condition is false or true. Condition I equals 10 is always false. Yes, it is. But even then, this code runs. Now let's look at for loop. So a for loop is used when you know exactly how many times you want the loop to run. Let's say for I in 1 to 10, 1 and 10 both included. Let's increase the sum variable by 2. And then let's print that sum. So it's gonna go from 0 and increase by 2 for 10 times. Let's see what happens. Also, we can just write it here so we can see exactly how it changes every time the loop runs. As you can see, it was 0, then 2, then 4, 6, 8, 10, 12, till 18. So that's for loop. A for loop can also be used for looping through the items in a list, but we haven't covered lists yet. Let's just say val fruits equals list of some fruits. Apple, banana, and orange. For fruit and fruits. Print the fruit. It's going to do exactly that. Apple, banana, orange. Which it does. Okay. Now let me tell you this. To define a range, we use this 1, 2 full stops, and 10. This defines a range from 1 less than equal to from 1 to 10, where let's say a variable I, if it's between 1 and 10, like we saw in that code, it means that I is between 1 and 10, like so. We can also define the range without using the double full stop notation, like this. But in this range function, the end is exclusive. That means it's not 1 less than equal to and 10 greater than equal to. It's more like I would never reach 10, because I is less than 10 in that case. Okay, let's just see an example, because it's getting complicated. For I in range 1 to 10, I'm going to show you that it never prints 10. Also, in a for loop, you don't have to declare it. You don't have to declare the variable. You just write it here, and it's declared. You don't have to write var I equals 0. No, you don't have to do that. In a for loop, it's if you write the name here of the variable, it's declared. Like so. Now we expect 1 to 9. We don't expect to see 10 here because it's a range, and the end is exclusive. So 1 to 9 are printed. You can see no 10 here. And if we use 1 double full stops in 10, then it should print that 10. And it does. 1 to 10. So according to your use case, you can use a range function for this, or you can use this. And for arrays or lists, you can use use it like this. Name the variable oneFruit in fruits in this list. Let's say fruits list. And now let's look at when expressions. Comment this code out. And when expressions. So when expressions are like switch case in other programming languages. So you define the case here. Oh, you define the main variable here. And let's say grade equals A. Let's make a when expression on the variable grade. Now, if the grade is A, then execute this code. Closely look at the syntax for this when expression. A, and then grade is A. Let's just make this a string instead. That way it's better. So A, or if the grade is A plus, then run this code. If it's B plus, then run this code. And so on. Let's just declare two more. C plus, a B and a C plus. Finally, a default case. Else. That's what we call it in this language. We don't call it default. Okay, else. Just do this. Okay, now let's look at this. When grade is A, we can print good. When it's A plus, we can write excellent. If it's B positive, a B plus, yeah. Then we can say average. Yeah, that's some strict marking, but who am I to blame? Average. And let's just say okay. And for a C grade, you can do better. What the hell? And in the else case, so else would be a case when the grade is not defined, because maybe it's empty, like this, empty, nothing. Or maybe it's something ridiculous like X, Y, Z, whatever. So in that case, grade is invalid would be printed. Now let's check this out. So grade is A should give good. Yeah. Grade is C plus should give you can do better. Yeah, that. And in the case that you use, in the case the grade is XYZ, it's going to say grade is invalid because it is. We didn't define it. That's why. It's wrong. Okay, that's it for this lesson. Meet you in the next one. Let's look at functions, nullability, and scope. A scope is a place where your variables are visible and accessible. For example, the variable name is defined in the global scope, so any function can use it and modify it. Like this. So it's going to be maxine now because we changed it inside the function main. But if you define something inside the function main and try to change it outside, it won't work because that variable would be defined inside the main function in the local scope of the main function. Like this age variable. If you try to access it in another function, it won't work. Unresolved reference age, because it's not defined in this function. It's local to the main function. Now let's look at functions. And how do we declare functions in Kotlin? So we do that by this keyword fun, and then you give the function a name like add, and then you give two parameters for this function. Number 1 int of type int, and number 2 of type int. And the return type would also be int. Now you can return number 1 and number 2. Now print line add 2 and 29. So you call a function using parentheses, and you also give it the arguments that it needs. Like this function needs two parameters, number 1 and number 2. So we gave it number 1 and number 2, and now we're going to print it. 31 as expected. Now let's make another function so you can familiarize with this syntax. Twice function. It's going to take a number and calculate the twice of that number. So number of type int, return type would be int. You use a colon and then define the data type for the return value. So here we're going to return number num times 2. So it's going to be twice of the number that it was given. Twice. As you can see, it's double now. Yeah, we can call it double actually. Double. This is called the snake case, where we capitalize every distinct word. Double the number. And now we gotta change the name over here too. Double the number. Now I didn't use double as the function name because it's a data type. Now it could cause trouble, but it doesn't, so okay, no problem. Let's just name it double the number. Okay, that's functions, and let's define another function which returns nothing. In Kotlin we call it unit. It's going to display something, display emojis, and the return type would be unit. So it won't return anything. It would just print something. Now let's call this function display emojis. And we can see the output. Now we're done with functions. Well, almost done. Now let's define functions as variables. So in Kotlin we can define a variable like add, which we did over there, and we need to define the type of function it is. So this function takes two integers, int, and with a minus sign and a closing angle brace, which forms an arrow, and the return type being an int. So we can basically give it the add function that we made. And just like that, we have this add function inside our sum function now. So we renamed it in a way. Now if we call sum with 2 and 3 and display it, it would do the same thing as before. Just like that. So you can see that we can change the name of the function. We can keep the functions in a variable. Well, we can also define a new function using this syntax above. Now let's say there's a function which takes two integers and also returns an integer. And we define the function right here with two curly braces, opening and closing, and a and b parameters, and then you get a minus b, the value which is returned. Now let's use this minus function. So 100 minus 1. As expected. And now we're going to look at nullable types. So nullable types. So nullables are those variables which can accept null, which is this. So null represents an absence of value. And many a times in programming you will encounter that a variable which is supposed to have a value doesn't have a value. For example, the name of type string, and to make it nullable we need to end it with a question mark, and the name can be null. Similarly, the age of a person may be null because when the form was being submitted, the name and age were not passed. So now they're null. And we can check for null. If the name isn't null, then we're gonna print hello name. And it doesn't print anything because the name is null. Now this handles the condition where our name would be null. But if it's not null, then it's going to print normally, like hello Max. And it does. Now let's look at save call. Now save call works in this manner. Let's say we have this name string. And you can see that it's got a number of properties and methods. We're going to discuss this later. But now let's just say we're going to get its length. So the length for this string could have been null. That's why we used the save call operator. It handles the case when the property or a method you're going to call on an object could be null. Now let's print this, and it should give should give 3. And it does. Now let's look at the always operator. So this is used for a case when instead of a null you need to pass a definitive value, like the name. If the name was null, but you actually wanted to pass an actual name, so you just pass it with a question mark and a colon. You just pass John Doe. So now this if statement would be true, and it would run hello John Doe would be the output. You can see that. And finally, the non-null assertion operator. Let's see where it's used. So the non-null assertion operator is similar to this save call operator, but instead you are 100% sure that the name here would not be null. So it's a assertion, and if it's null, then your program's going to crash. So don't use this. Try not to use this, because in case it's actually null. As you can see, we ran into an error, as expected, because name with the save call return a null, but with the assertion operator it crashed our program. So that's save call and non-null assertion operator for you. Looks like I missed 2 logical operators, which are and or, represented by these vertical dashes. Now vertical lines. So if let's declare 2 variables, is raining, let's say it's true, and is sunny is false, or playing equals false. So if is raining and playing, then let's say enjoying. Now, in case is raining is true and playing is true, only then are we going to execute this print line enjoying. Otherwise it would be false and this if statement would not execute. Let's try this out. Okay, we need to comment this code. This one too. So, because one of the statements were variables were false, the entire expression becomes false. In case both of them were true, then enjoying would be printed on the console. You can see that. Now what if it was or? Is raining or playing? Now if one of them is true, like if it's raining, then it's going to become true. And enjoying would be printed on the screen. Or if is raining is false and playing is true, even then the if statement would execute. Now what if both of them were false? In that case, we would not get enjoying printed on the screen. Now that's and or logical operators.